Welcome back to our ongoing exploration of fascinating integer sequences from the OEIS database. Today we're diving into A000135,
Okay.
titled Number of Partitions into Non-Integral Powers.
Right.
As number theory students,
Yeah.
I think you'll find this one particularly interesting.
It is a sequence that might seem a bit complex at first glance,
Right.
but it leads to some intriguing mathematical ideas,
Okay.
especially when we start connecting it to other fields.
So let's break it down.
Yeah.
What exactly is A000135 counting?
Right.
I know we're dealing with partitions,
Uh-huh.
but what makes these partitions unique?
So you're right. It all starts with the concept of partitions.
Right.
As you know, a partition of a positive integer is simply a way of writing as a sum of positive integers.
Right.
Where A000135 gets interesting
Yeah.
is the type of powers involved. Instead of using whole number exponents, we're using fractional powers.
Okay.
Specifically, we're raising integers to the power of 2/3.
So we're essentially squaring the cube root of integers.
Yes.
That sounds a bit unusual.
Yeah.
What's the motivation behind choosing this specific exponent?
That's a great question.
Yeah.
And honestly, the beauty sometimes lies in the unexpected.
Right.
Choosing this specific exponent leads to some fascinating connections.
Okay.
Particularly with statistical mechanics.
Okay.
But we'll get to that later for now.
Yeah.
Let's focus on what the sequence actually counts.
Okay.
A000135 tells us how many ways we can express an integer as the sum of these unique non-integral powers.
Right.
Always using distinct integers.
Okay, I think I'm following.
Okay.
So for example, if n3,
Right.
the sequence considers all the possible sums we can create using distinct integers raised to the power of 2/3, ensuring each sum is less than or equal to 3.
Precisely.
Okay.
The OEIS entry gives us 6 solutions for n3.
Okay.
It starts with 1 raised to the power of 2/3,
Right.
which is less than 3. Then it considers 1 to the power of 2/3 plus 2 to the power of 2/3, and so on, up to 5 to the power of 2/3.
Okay.
Each of these sums is less than or equal to 3,
Right.
giving us 6 possible ways to partition 3 using this specific rule.
So the sixth term in the sequence, A000135, would be 6.
Correct.
This is fascinating.
Yeah.
But why would mathematicians choose to study partitions with this specific exponent?
That's where it gets really interesting.
Okay.
While the choice of exponent might seem arbitrary at first,
Right.
it turns out that A000135 has a surprising connection to statistical mechanics,
Oh, wow.
a branch of physics that deals with the behavior of systems with a large number of particles.
Now that you mention it,
Yeah.
I vaguely remember encountering something called partition functions in statistical mechanics.
Right.
Could there be a link?
Absolutely.
Okay.
The link lies in a paper by Agarwal and Alok
Right.
titled Statistical Mechanics and Partitions into Non-Integral Powers of Integers. They discovered that this type of partition problem, where we use non-integral powers,
Right.
can be used to model and understand how energy is distributed within a physical system.
So the way we can break down a number into sums of non-integral powers
Right.
has implications for how energy is spread out in a physical system.
Yes.
That's remarkable.
It might seem like a stretch.
Yeah.
But the underlying mathematical principles are surprisingly similar
Okay.
to understand with connection better.
Right.
Let's imagine a system where the energy levels are integers raised to the power of 2/3.
Okay, I'm picturing it.
Okay.
So if we have a fixed amount of total energy to distribute among particles in this system.
Exactly.
Okay.
And each particle can only occupy these specific energy levels, which are defined by integers raised to the power of 2/3.
Right.
The question then becomes,
Okay.
how many different ways can we distribute this total energy among the particles,
Okay.
ensuring each particle occupies one of the allowed energy levels?
I see where this is going.
Yeah.
A000135 comes into play here.
Yes.
Because it essentially tells us how many ways we can partition our total energy into these specific energy levels.
You got it.
Okay.
The sequence provides a way to quantify the different energy configurations available to the system.
Right.
It's like using the sequence as a tool to count the possible states of a physical system based on these specific energy levels.
Wow.
This is a powerful link between number theory and physics.
This is truly mind-boggling.
Yeah.
I wouldn't have guessed that a number sequence could have such a direct connection to physics.
Right.
But I'm also curious about the mathematical properties of A000135 itself.
Yeah.
We mentioned earlier that it grows quite rapidly. Are there any patterns or formulas we can use to predict its terms?
That's a question mathematicians have been exploring for decades.
Right.
Unfortunately, unlike some sequences with simple recursive formulas,
Right.
A000135 doesn't have a straightforward closed-form formula to calculate the nth term directly.
So it's not as simple as the Fibonacci sequence,
Right.
where each term is the sum of the two preceding ones?
Not quite.
Okay.
However, there are recursive formulas and asymptotic approximations that provide insights into the sequence's behavior.
Okay.
These methods involve more complex techniques.
Right.
And delving into them would take us a bit deeper into advanced mathematical territory.
I understand.
Okay.
It's fascinating to know that mathematicians are actively working on unraveling the mysteries of the 000135.
Yeah.
This deep dive is already revealing so much more about this sequence than I initially anticipated.
It's a testament to the fact that even seemingly simple mathematical concepts can lead to profound and unexpected connections.
Right?
And we've only just begun our exploration.
Yeah.
There's still much more to uncover.
Okay. It really highlights the interconnected nature of mathematics and how exploration can lead to unexpected discoveries.
Yeah.
So we've touched upon this connection to statistical mechanics.
Right.
But I'd love to delve a bit deeper. For our number theory students listening,
Yeah.
can you give us a more concrete example
Sure.
of how a 000135 applies to this field?
Absolutely.
Okay.
Let's consider a simplified model
Okay.
where we have a system with a fixed amount of energy,
Okay.
say 10 units.
Right.
And let's say the particles in this system can only exist at energy levels that are integers raised to the power of 2/3.
Okay, so our energy levels would be 1 to the power of 2/3.
Yes.
2 to the power of 2/3.
Uh-huh.
3 to the power of 2/3, and so on.
Exactly.
Okay.
Now, the question is, how many different ways can we distribute these 10 units of energy among the particles,
Okay.
given these specific energy levels?
So one way could be to have one particle at the energy level of 10 to the power of 2/3.
Right.
Or we could have two particles,
Uh-huh.
one at 5 to the power of 2/3,
Right.
and another at 5 to the power of 2/3,
Exactly.
and so on.
Precisely.
Right.
And this is where A000135 comes in.
Okay.
The sequence helps us count these possibilities.
Right.
It tells us how many ways we can partition our 10 units of energy
Right.
into subs of distinct integers raised to the power of 2/3.
So in essence, A000135 gives us a way to quantify the number of possible energy configurations in this system.
Yes.
That's a pretty neat application of a seemingly abstract number sequence.
It really is.
Yeah.
It shows how a mathematical concept from number theory
Right.
can have tangible implications in understanding physical phenomena.
This connection is fascinating.
Yeah.
But I want to come back to A000135 as a sequence itself.
Okay.
We've talked about how it doesn't have a simple closed-form formula.
Right.
But are there any notable properties or patterns that mathematicians have observed in its behavior?
That's a great question.
Yeah.
While a simple formula remains elusive,
Right.
mathematicians have discovered interesting properties through recursive formulas
Uh-huh.
and asymptotic analysis.
Okay.
For instance, they found that the growth rate of A000135 is closely related to the growth rate of another fascinating mathematical function
Okay.
called the Riemann zeta function.
The Riemann zeta function.
Yes.
I remember encountering that in my complex analysis class.
Uh-huh.
It's known for its deep connections to prime numbers, right?
Exactly.
Okay.
And this connection between A000135 and the Riemann zeta function hints at a possible link
Yeah.
between this partition problem and the distribution of prime numbers,
Wow.
which is a really exciting avenue for further research.
So exploring a seemingly simple sequence like A000135 could potentially lead to insights into one of the biggest mysteries in number theory,
It could.
the distribution of primes.
Yeah.
That's incredible.
It truly shows how interconnected different areas of mathematics can be.
Right.
Exploring one concept can unexpectedly illuminate other areas and lead to new discoveries.
This deep dive has certainly highlighted that.
Right.
We started with a sequence defined by a peculiar partitioning rule.
Yeah.
And we've uncovered connections to statistical mechanics,
Uh-huh.
advanced mathematical functions,
Right.
and even hints at potential links to the distribution of primes.
It's pretty fascinating.
It's amazing how much depth lies beneath the surface.
It's a reminder that in mathematics, even seemingly simple concepts can harbor profound secrets waiting to be uncovered.
Yeah.
And often the most exciting discoveries come from exploring those unexpected connections between different areas of study.
Speaking of exploring,
Yeah.
are there other areas of mathematics behind statistical mechanics and potentially prime number theory
Right.
where a 000135 or similar sequences might have applications?
That's a great question,
Yeah.
and it's one that researchers are actively exploring.
Right?
One promising area is combinatorics,
Okay.
the branch of mathematics concerned with counting and arranging objects.
I could see how partitions, the foundation of A000135,
Right.
would naturally connect to problems in combinatorics,
Uh-huh.
which often involve counting different ways to arrange or select items.
Exactly.
Right.
And the specific constraints of A000135 using distinct integers raised to a specific fractional power
Okay.
could potentially model unique combinatorial scenarios.
Okay.
For instance, imagine you're designing a system where you need to distribute a limited number of resources,
Okay.
represented by our energy units,
Right.
across different points,
Uh-huh.
and each point can only accept resources in specific quantities,
Okay.
dictated by our non-integral powers.
Right.
A000135 could help you understand how many ways you can achieve this distribution.
That's a great example of how a seemingly abstract mathematical concept can translate into a practical problem-solving tool in different fields.
Absolutely. And
Yeah.
that's just one potential application in combinatorics.
Right.
There could be many more connections waiting to be discovered.
This is incredibly insightful.
Yeah.
It's clear that A000135, despite its seemingly niche definition,
Uh-huh.
has far-reaching implications and potential applications
Yeah.
as number theory students. It's inspiring to see how a concept from our field can branch out and connect to other areas of mathematics and even physics.
It's a testament to the beauty and power of number theory.
Right?
Often the most abstract concepts in this field turn out to have profound connections to the real world and other areas of science.
Before we wrap up our deep dive into A000135,
Okay.
I'd love to leave our listeners with some key takeaways
Okay.
and potential avenues for further exploration.
Right.
What are your thoughts?
I think one of the biggest takeaways is to always be curious and open to exploring unexpected connections.
Right.
As we've seen with A000135,
Uh-huh.
a seemingly niche sequence can have surprising links to diverse fields,
Okay.
like statistical mechanics,
Right.
the study of prime numbers and combinatorics.
It's a great reminder that mathematics is not a collection of isolated topics, but a web of interconnected ideas waiting to be explored.
Absolutely.
Right?
And for those interested in delving deeper into A000135,
Yeah.
I'd recommend exploring its entry in the OEIS database. Reading the paper by Agarwal and Alok that highlighted its connection to statistical mechanics,
Uh-huh.
and perhaps even researching the Riemann zeta function to understand its potential link to prime numbers.
Those are excellent resources for anyone wanting to continue their exploration of this fascinating sequence. It's been an incredible journey exploring this sequence and uncovering its hidden depths. I feel like we've only scratched the surface.
We certainly have, and that's the beauty of mathematics.
Yeah.
There's always more to discover, more connections to make, and more mysteries to unravel.
For our number theory students listening,
Yeah.
what advice would you give them if they want to explore sequences like A000135 further? What skills or approaches would you recommend they develop?
That's a great question.
Yeah.
I think one of the most important skills for any aspiring number theorist is to develop a strong intuition
Right.
for patterns and relationships.
I'd say.
When you look at a sequence like A000135,
Yeah.
don't just see a list of numbers.
Right.
Try to visualize the underlying structure, the rules governing its growth,
Uh-huh.
and the potential connections to other concepts.
So it's about going beyond the numerical representation
Yeah,
and trying to grasp the essence of what the sequence represents.
exactly. And don't be afraid to experiment, to play around with different representations, to
Right.
test different approaches.
Okay.
Sometimes the most insightful discoveries come from asking unconventional questions
Uh-huh.
or trying seemingly unorthodox methods.
It's about embracing that spirit of curiosity
Right.
and allowing yourself to explore different paths, even if they lead to dead ends, because sometimes those dead ends can reveal unexpected insights.
Absolutely.
Right.
And another important skill is to cultivate a habit of connecting ideas from different areas of mathematics.
Right.
As we've seen with A000135,
Right.
the most fascinating insights often emerge at the intersection of seemingly disparate fields.
Right.
So don't limit yourself to just number theory. Explore other areas like combinatorics,
Right.
analysis,
Uh-huh.
even physics.
Right.
You never know where you'll find inspiration or connections that will illuminate your understanding of a particular concept.
It's about building bridges between different areas of mathematics and recognizing that the beauty of this field lies in its interconnectedness.
Right.
Well, I think this deep dive has been incredibly enlightening,
Yeah,
not just in terms of understanding 800135,
right.
but also in terms of appreciating the power of exploration and the interconnected nature of mathematics.
I completely agree. It's been a pleasure exploring these ideas with you and our listeners.
Great.
Hopefully, this deep dive has sparked some curiosity and inspired further exploration into the fascinating world of integer sequences.
Thank you for joining us on this mathematical adventure. We hope you've enjoyed this deep dive into A000135 and that it's inspired you to continue your exploration of the rich and often surprising world of number theory. Until next time, keep those mathematical minds curious and keep exploring.